Alright, another example of the disk method, except this time we're going to take the enclosed region, and in this case our region is bounded by the line x equals 0, y equals 4, and the parabola y equals x squared. So that enclosed region, we're going to rotate it around the y-axis. Okay? So if you probably could, you could maybe envision that one a little bit easier. You're kind of making what would look like a cup in a sense. Okay? Except not open at all. Alright? Just a solid.
Almost like a Hershey's Kiss, except with all the way out.
Yes.
Can you compare everything to food, please?
So, the difference is here, you're rotating it around the
Different shapes of food.
y-axis, so it's kind of like doing the same problem like we talked about yesterday. We're just kind of looking at it sideways, okay, but we're doing it in terms of y instead, okay? So, here, when you use, your dy, if you will, just make sure you have everything in terms of y, alright? So pi times the antiderivative from where to where?
A to B.
Which in this case is going to be where? 0 to 4.
You have to go up on
Because you're going...
access.
Now what's the function going to be?
Do you have to get inventory of one?
Mm-hmm. Square root of y. If y equals x squared, then x would equal the square root of y. Right? For instance here, when x is 2, y is 4. Right? If you plug in a 4 for y, you get 2 for x. Okay? So the square root of y, that's your function, squared, because it's pi times the radius squared
That's nice.
times the height, which in this case is just dy.
Or dy.
So,
So can we just make that y?
yeah, that's what you're going to do. I'm sure most of you are going to roll that right now. So, let me come back to it, maybe,
Okay. That's
and just finish this. So, pi times antiderivative from 0 to 4, that will just be y dy. So, pi, 1/2 y squared
Yep.
from 0 to 4. And what's that, 8 pi?
Square 16 times 8.
So 8 pi units cubed.
Will we miss a half of it if we
Right.
forget the units cubed?
No, you don't need to. You don't need to label it here. It's not a story problem about something. When we start doing applications, then you want to put a label on it. But you don't need the units cubed. That's fine.
I just put 8 pi.
What's that?
I just put 8 pi.
Yeah. Yep.
Sweet.
Okay. There was a quick question. Again, Carla, what was your question?
Like y is the height dy or dx.
Sure. So if you can try and envision taking a whole bunch of really skinny cylinders.
There's a good picture of it in 459.
The height right here is really your change in y, or the difference between a couple y values right here. And the difference between those y values as they get really, really, really small, it could be known as delta y, a change in y. And that's very similar to what dy is, because it's an instantaneous change in y. Remember when we did derivatives? Is there a good picture to go with it, you're saying, Luke?
Yeah, on 459, where it shows that shape being shown as a bunch of cylinder is stacked on top. The top right.
So he's looking right up here.
That's all.
Yep. So that delta x, or that small change in x, you just gotta envision it as in y, but you get the idea. So that delta x represents the very tiny change in x, and if we would, do derivatives or integrals the long way, we would do the limit definition as delta x approaches 0, so those as they get smaller and smaller and smaller, you would approach the actual volume of those figures. So that's why it represents the height there, yeah.
So since it's being rotated on the y-axis, is that how we have to change it to the x-axis?
Yes. Yep, because we're rotating it around the y-axis, we had to write it in the function in terms of y.
Does it not
dy.
have to be plus or minus y?
Plus or minus the
minus
square root of
Well,
y?
Yeah.
Square-
It wouldn't. It would if we were also doing
Okay.
that part down
But
there.
like if we didn't have the picture, we would have to do
Um,
Would it ever
no,
matter?
because I'd give you enough functions to tell you this is the enclosed region I'm concerned with.
it. Okay.
Yeah, I had a
Okay.
deflection current too today, it's been bad.
Wait, what, does it really matter though?
For
Because
this,
you're
no.
squaring it anyways, right?
Because the negative square
Correct,
and positive
yeah,
square.
it wouldn't
So-
matter.
Okay,
Mhm.
so even if it was below.
Before I